Hello, everyone. Welcome to a new edition of our workshops on Open Web Academy. Today, we're going to talk with you about the development of decentralized interfaces on Ethernet code. Today, we have a guest that we're going to explain you about Bara Network and the integration of Ethernet code with Bara. That is Aditya. Aditya, are you there?
Yeah, I'm here. So if you can see me,
Yes. I can hear you. I can see you. Hello.
yeah, nice to meet you.
It's me, you too. Well, do you want to share your screen and start with the conversation?
Yeah, sure. So I'm also sharing the link into my warranty Telegram, so maybe other people can join as well. Yeah.
Sure.
Yeah, sure. So if they want to join, they can join later on. So let's get started.
You can start whenever you want. Are you going to share your screen to present some slides or something?
Yeah, I will share it just now.
Nice. Nice.
Okay. Just a minute. Few people are joining in from here as well.
If you want, we can start. And also, this presentation is going to be recorded to be uploaded on our YouTube channel of Open Web Academy, so the people can check
Yeah,
this session.
sure. So we should start, I guess. So this is how it will go. First of all, we will explain about basics of blockchain, what blockchain is, and then we will move towards Vara and Vara integration will, right? That works?
Yes, it's okay.
Yeah, sure. So first of all, we can do a small intro if you want about, I can know about you and you can know about me as well. Yeah, go on. You can introduce yourself so other people can also know.
Sure. Well, I'm Luis Daniel Méndez Castellanos. I'm part of Open Web Academy. Open Web Academy is an organization that it's focused on the education of the open web. Today we're going to show you some uh, uh, a workshop that is focused on the development of decentralized interfaces on Ethernet code. In this case, Ethernet code is a tool that we are going that we are developing to make some to create interfaces on blockchain. So in this session, we are going to tell you about more about this.
Yeah, sure. So my name is Aditya and I'm a developer at Gate Foundation India. Like I do develop stuff for Vara Network India. So we recently started and we are growing rapidly because we around have 500 followers on Twitter and on Telegram. We are growing rapidly. Yes, it's nice to be here and lovely to talk to you guys. Yeah. So yeah, let's get started. Is it visible?
Sorry. I can see the screen. Yes. Everything's okay. If you want, I can
Yeah,
show the
sure,
presentation.
sure, sure. No problem. You
There's
can
no
do that.
problem.
So, in the coding part, we can do something different.
Okay, thanks. And let me share my screen. Nice. So we're going to start with the workshop. The workshop is the development of decentralized interfaces. This is focused on communities and universities, and we're going to work with Eternal Code. First of all, anyone, someone have have read the terms and conditions of Instagram, Facebook, or another social media? Well, this is a fragment of these terms and conditions on Instagram. When you share, post, or upload intellectual property rights protected content, such as photos or videos, in our connection with our service, you grant us a worldwide, non-exclusive, transferable, sub-licensable, royalty-free license to use, distribute, and share on intellectual property rights protected content, like photos or videos, in our connection with our service. Well, technically, here is telling that every post, every photo, every video that you post on Instagram, Meta have the access to use for their promotions or anything that they want to use this content. And you, when you post it, you are leaving them do it everything that they want with everything of the content, like photos or videos. So, who do we trust? In this case, as we know, AWS and Google Cloud are the principal providers of the services on internet. I read yesterday that AWS have the 33% of the services on internet on their servers, and Google Cloud another big proportion. Is internet really safe? In this case, AWS have the 31%, and also Cloudflare, that is another service that provide services to to load our applications, like another services like Spotify and Netflix have another types or mechanisms to ensure that everything is encrypted. In this case, Cloudflare use 100 lava lamps to generate an encryption passphrase to make sure that everything is secure on the internet. Now we have two examples of systems. As you can see on this diagram, here we have a centralized system. In this case, everything is focused on the financial regulator, and every institute shares the data with this central identity. And we have a distributed system that every node share data on every side. As you can see, these two can share data, and also these two, and everything it's like a cluster. Uh, taking this taking this in mind, this is how blockchain works. First of all, with data logging, as when a transaction is signed and recorded on the blockchain, it's put in a block. So here we have the information saved on blockchain. It's unalterable. Each block is connected with the previous block and with the next block. And also, everything is on chain, so the data recording is perpetual. And here we have another diagram to represent how the blockchain can work. As you can see, here we have the node A, B, C, and we want to go to the C node. And we have some nodes on the center side. We can take any road to go to C. And also we have the evolution of the web. As you can see, we have the web 1.0, 2.0, and 3.0. On the 1.0, we only can interact with the information that is connected on the dedicated services. In this case, we have Netscape on another services. In the case of the Web 2, it's technically the actual paradigm that we have on the web. And we have Facebook, Airbnb, and Uber. In this case, we can consume the information and also publish information. But on Web 3, we can do the same things on the Web 2, but also we can have the ownership of our own information, and also is hosted with AI services and decentralized data architectures. In this case, this line represents the value of the evolution of the web. In the web 1.0, the value is 1.1 trillion of dollars. In the web 2, 5.9 trillion, and the web 3, we don't know how we can evaluate this right now. The value of blockchain technology, according to Gartner, the value is about $3 trillion on 23. This is an interesting number because blockchain is growing every day, and we can see the markets and other applications that are using blockchain technology. Well, blockchain is technically something like that. As you can know, Ares, uTorrent are applications that use the protocol peer-to-peer to interact with another users and download their data. If you have a file that you want to share with the people, you can publish it on uTorrent, and the people can have access to this file and download it like a center point on this case. Well, here we have the traditional app structure. As you can see, we have the client that want to interact with the front end and a backend that is hosted on the web server. And here we have the app server and the database. Everything is based on a web server. It's a Web 2 application like we know. But actually, we have hybrid application. In this case, it's an application using blockchain to interact with information. As you can see, here we have the client. The front end is on a web server also, and is interacting with the app server. But the part of the interaction with the data, we have a backend and all the data hosted on blockchain. And here we have the decentralized interfaces with Ethernet code. In this QR, we have the link to our Telegram group. If you want to join us on this community of Open Code Academy, I inviting you to scan our QR. I'm going to let you a few minutes to scan it and enter to our community. Here on Open Code Academy, I'm going to share with you some content about the technical, decentralized frontend, blockchain, and other things that will be interesting for you. We're going to wait a few minutes to wait that you want to enter to our Telegram group. Nice. We're going to continue with the presentation. Now, uh, we have a diagram with the example of a usually app deployed on Web3. It's a hybrid app. As you can see, here we have the user with their wallet address. We have the front end that is hosted on a web server, and we have the backend that is hosted on blockchain. But the principal problem is that the front end is hosted on a web server. What happens if the country limited the service to, for example, AWS, Google Cloud, Cloudflare, GitHub? We can access to our site and or the app because it's limited access by another rules that we can know. Maybe it's blocked the port or another service. Here we have Eternal. Eternal is a tool that guarantees the resistance of censorship, promoted the free and open source software philosophy, facilitating the development of application in emerging technologies, and allowing the transparent interaction between Web3 networks. In Eternal, there are four pillars, principally the access, and the access that every component that is deployed on Eternal, it's available until a gateway it's running. Well, we are going to talk more about later. The security, all the code of the front end that is deployed on Eternal is saved on blockchain. Having all the access to the characteristics that blockchain has, we have the inalterable sectors of content. We have some registers of the movements that we made on the code and other things that can give us the blockchain. Composability. In this case, Eternal code is based on React, so we can create or the app like something like Legos. So we can create little components that can join to another ones and create something bigger. And one of the most important things is the chain agnostic that that is the Ethernet code have support for so many blockchain, have support for new protocol, all the AVMs available right now, and also we have support for paranetwork. The Ethernet code architecture. Part of the pillars of Ethernet code are the components that the people are going to develop on our community and publish it, and everything to be it's going to be open source, so everyone can access to all the codes of the community and fork it and create a new one. The second one is the blockchains that we can interact and save the code on, at least right now on your protocol. And finally, the gateways that are the access point to the components on our platform. And also, Eternal Code is an open source project, so you can take the repo of Eternal Code, fork it, and create another gateway to give the people access to our components. The stack of Eternal Code are two principal things. The first one is React, that give us the access to the components framework. This is a web framework to develop some fronts. In this case, we can create components to create something bigger and create our the app. And the second one is Bootstrap, that can give us the access to multiple classes of CSS and make easier to our interaction with Eternal Code and the styles on the app. Let's get to work. So I'm going to give the mic to Aditya, who is going to talk about the integration on Eternal Code and give you information about paranetwork.
Yeah, sure. Thanks a lot, Luis, for this. Yeah, so yeah, let's get started. Just uh, now is it visible?
Yes, we can see your screen. Everything is okay.
Yeah, so we will talk about the first of all Vara and then how it is integrated with an account, right? So yeah, let's get started. So what is Vara? Yeah, so we will discuss about governance, tokenomics, gear protocol, and substrate. If you know about the gear protocol, anyone, because I see a lot of faces that are already familiar with the tech stack and everything, like Midge and everyone. So about Vara. So Vara use cases lies in DeFi, DEX, NFT, Metaverse, SocialFi, Marketplace, gaming, RWA or tokenized RWA. Okay. So Vara enables you to develop programs that was like asynchronous interaction. For example, if you are building a complex dApp, you don't want that sequential execution. You want everything to run in parallel for like multiple tasks to run in parallel. So Vara has parallel execution with asynchronous programming, and you can do that. So Vara functions are scalability, performance, like its cutting edge features related to gasless and signless transactions, and a lot more. So you don't want your head spin like that when you interact with the blockchain with a lot of fragmentation and everything. So you have a lot of like abstracted thing. For example, you have a platform built in for you to deploy your contracts and everything. Scalability. If we talk about blockchain scalability, how we can scale that. So first of all, the major things are increasing the block size using proof of stake or POS, implementing side chains, shredding. So these are the things that we can use to scale the blockchains, because when blockchain was built initially, it doesn't had this that much use cases, but now it has with gamify or DeFi. According to the needs, the blockchain has to scale. Otherwise, a lot more congestion will happen and it will not able to scale at all. How does for a network work? So a block time is around 3 seconds. It is 3 seconds due to some reasons. Message per seconds are 2 to 3,000. The block time was chosen to balance the spawn rate. As we talked about, we don't want the sequential processing. We want tasks to run parallel, so that this gives you the seamless experience when you interact with the blockchain. Inside a block, there are several processes taking place. For example, 5 messages in a block, the processing time of four of them is 150 milliseconds, and the last one is 200, right? Processing all these 5 messages in a batch will take maximum of 200 compared to 800 milliseconds for sequential processing. So that's how Vara scale. And a performance, Vara uses WASM, which allows you to optimize optimism format. Good architecture leads to low cost performance. That's why it has a low cost. And if Vara network implements, it has gasless and signless transactions. Most of you guys know about that. So WebAssembly is considered the king of binary formats. We all know if you are a programmer or a developer, this one is for you. Persistent memory. This is a Web 2 and Vara Network is implementing it in a Web 3 space. When working with memory, there's no shared storage. You want, there should be no shared storage. Each program has access only its own memory, because that's how it should work. All program memory is stored at once. While writing a program, we work with local memory. The system performs only with two operations during program execution. Lazy pages, for example, the smart memory loading techniques allows you to opt in only necessary memory pages during execution, because you cannot, like, you need that necessary pages instantly, right? With gear protocol security, Am I audible or clear? Just asking once again. Louis,
Sorry?
am I audible and clear right now?
Yes.
Yes. So safe substrate is supported by secure actor model architecture for, like Vara has active built-in actors. Okay. So Vara has its custom block producer. Even in the event errors, the custom block producer will not stop network and continue to produce blocks and process transactions from the pool. So this gives you the surety or authority of gear protocol security. Now we use Rust for smart contract development. Now it has integrated with Snails, and you can do that with internal code. We will see and module structure of programs and test toolings as well. So developer experience, user experience matters the most, and the higher level of abstraction while developing applications. You don't want to jump from one technology to another. You want that seamless experience when you're developing an application. So support for most popular programming languages, for example, Rust and assembly script. You know that Rust is the greatest programming language ever because due to its features, the minimum blockchain context required for programming, a growing ecosystem for development. So as a developer, you need a platform with like all the resources, but not you don't have to go from one place to another, but you can do a lot of things together. So yeah, I guess we can talk about the integration part if you guys ready, Luis, or
Uh, yeah, we can show it to the people. Uh,
so this is also second one. So Tenna code just like everyone, like Luis still told us, is a tool for ensures censorship resistance and promotes false philosophy. For example, free and open source software philosophy. We want that open source software because so that it is more accessible to people. It facilitates the development of applications, emerging technologies, transparent integration in Web3 networks. Like the pillars are components, blockchains, and gateways. Tech stack is simply refined and the one of the best, React and Bootstrap. So let's get to work. We will get to this. So we will talk about the integration, how it integrates with Vara, Vara network for BOS interaction. So as you see in this image, you can easily see that the architecture will be follows. The front end will be deployed on the blockchain operating system on your protocol network, while the backend will run entirely on Vara network, entirely on Vara network. This ensures that your applications are executed in 100% decentralized manner on the blockchain. So this is one of the revolutionary thing that I have seen personally, and you can easily see that building a dApp full in a blockchain, you have to like in previously you have to get something centralized, but now with this you can build your 100% decentralized dApp, right? So how do I deploy my component? So maybe Luis, we should head over to a website or continue like this.
you can continue, and we're going to show the
Yeah, after this.
uh,
Okay, got it.
after this.
Yeah. So how do I deploy my component? So that's the question, right? So you can easily follow the website. We can share it later on. It has everything that you need. Okay. So yes, completely. So as a tech stack, we already know that it uses Rust, JavaScript, HTML, and CSS, and optionally Bootstrap 5 for styling. You need styling for your apps, right? Snail contract interactions require generated elements and specific character for proper functionality syntax. Now we got to the syntax part. Var interacts elements follow a specific syntax and must be called correctly. We will see what this means. Usage, like elements are used as React components like var network dot this, and let's move forward. So we have Different types of invariants can be found to perform actions within the BOS component code. These invariants are as follows, like var network.wrapper, or like we will see what this means, not just theoretically, maybe with practically as well. So we have these three, and what this means, right? So var network.wrapper function encapsulates the code, the whole code, encapsulates the whole code, ensures the user has a connected wallet. That's the most important part for interacting with the Vara network, and usage called as a React component. For example, you are encapsulating your code within this, right? Vara network.wrapper, and you are encapsulating your code in this. Then we have Vara, uh, like you can adjust your customizable size as well here with this one. Function displays a unique icon based on the unique user's wallet address, similar to Polkadot applications, as we all know. Usage called as a React component with a customizable size. So it is written 30, but you can customize according to your needs. One network dot ident just the icon size is 30, or maybe you can do 50, 20. It depends on you. So this gives you a lot of flexibility as well. So with the snails interaction, this is a more abstracted way, but in the website and docs, it is written in a much more detailed way with a lot of examples. Function enables interaction with Vara network via snails type contracts. So you should explore snails, allowing read and write operations. Usage. Let's talk about the usage as well. Uses the interact property to execute function within the BOS components that we talked about. Available functions are send query, reads data of the contract, right? Sign transactions, signs and send those transactions, get account info, retrieves wallet and account details that you need. Okay. So as you know, like if you missed it, this is the Telegram group of Ternanwood. You can scan it and you will just wait for 30 seconds. Most of you guys are already there, I guess. We can move forward. Maybe Luis. Yeah.
Sure.
Yeah. So if you want to join Vara Network India, Telegram, or the Twitter, you can join from here. We will also wait 30 seconds and then we will move to the practical implementation with Luis. Yeah, sure. So we can move. Okay. I'm stopping the screen.
Nice.
Yeah.
Okay. Thank you so much. Uh,
My pleasure.
we're going to start with the practical implementation of Vara Network on Eternacode. Well, first of all, we have the platform on our navigator. As you can see on the chat, I let you the URL to go to Eternacode. We have in this case the mainnet version, and also we have available right now the testnet version of Eternacode. It's testnet.eternacode.dev. It's one of the recent updates that we did on Eternacode. So we're going to show you some examples. First of all, as you can see, we have the home screen of Eternacode. Maybe all the names are on Spanish because the previous workshops are focused on the Latin America people, but we're going to update this to be on English because it's going to be available for everyone on the world. Well, first of all, we have the sales examples. As you can see, we have 4 examples to be checked. And if we click on the basic example, as we can see, we have the basic integration. But if we click on this button on the 3 lines, as you can see here, if we click here, here it's telling me to edit the widget. But if you do click on this button, it's going to tell you to fork this widget because I'm the owner of the widget. And if we click here, as you can see, it's going to uh, send us to the editor on Ethernet code. In this case, we're implementing a BFT contract. This is one of the standards to the fungible tokens on Vara network. And here we have some instructions. To use the BFT extended contract, we need to be the owner of the contract or have permissions to be able to mint on this contract. First of all, we create the construct with the contract ID. As you can see, here we have the direction of the contract of the BFT extended that we have. In this case, we have the IDL of the contract, and here we have all the services, functions, and queries that we can do on this contract. And we start with the code. Well, as you can see, we have some states. The use state is part of React. Here we can save data and we can update it between the component and make sure that everything is saved okay. As you can see, we have the FT data, FT name, FT symbol, FT decimals, FT total, minters, the account of the user, and the response. Well, as you can see, we only have here the code, but if we click on preview, we can see all the code rendered that we have here, and we can render it to check the functionality of this component. But if we make a new change on the code, for example, here, and we are like something like that. If we change the text, we can click on preview and see the changes alive. This is interesting because we don't have to import any package or library. We don't have to create a new service on our computer, and everything is 100% online. This is good because if you have a basic PC with 6 gigs of RAM, 8 gigs of RAM, or something that is not so powerful, we can do your dep and make the change live and work from anywhere because you can save all the code on blockchain and recover it to edit it again. Well, as you can see here, we have some elements, some custom elements to implement Vara network. First of all, we have the Vara network.wrapper. Let me do zoom here. We have the wrapper to make sure that the people have the wallet selected. And here we have a div, and we have some classes of Bootstrap, as you can see, border flag, p3, in this case is padding 3, and rounded. We have a title tag, and here we have the Vara network dog sales interaction element. As you can see, here we have the trigger. In this case, we are going to call the get account info here, and we create a button that on the action on click, we set the account of the user on the state of account. And if account exists, we click on reload account information, or if it doesn't exist, we get account information. We're going to see it on the preview. In this case, is this button. If we do click on it, we can see the account data. In this case, it's my event icon and the name of my account and my direction of this account. Now we have the second button. We have in this case on the trigger, the send transaction, get account info, and send query. This is a more complex implementation of sales interaction because we are going to use the 3 functions available here. And also we create a button with the action on click. In this case, we get the information from the account, in this case the decoded address, and save it on a constant. We create a value of 10, and here is important. We create a constant with the data of the transaction that we are going to send. And here is the contract ID. This contract ID we declared before, as you can see here on the code and the line 6. And also we have the IDL. In this case, the service name, it's BFT. Here we have the service name, and here. And the method that we want to call, in this case, is the method mint, and the arguments that receives the method. In this case, this parameter is optional because maybe the method doesn't need arguments to interact with it. So if the method doesn't need it, you can not don't send the arguments. In this case, we send the account that it's going to be mint the token and also the value of the tokens to be minted. And here we have a constant with the TR name, and this send transaction. In this case, we're going to send the data that we want to send the transaction. And here is something important. Technical doesn't support the async await calls, but for this type of interaction with Vara, we are going to use the promises. Here we have the promise of on TR, that is our transaction, but then we recover the result, in this case is res, and we can show it on console and set response. In this case, this computer doesn't have access to this contract, but we are going to show you the interaction with the contract that we have permissions to meet. If the res exists, in this case, we load the information of the total supply and show it on the screen. And here we have the send query part. It's another button on the preview. As you can see here is the query. In this case, this button is, we set the FT data on true. We create the basic information to create the queries. Is the contract ID that we are going to call, the IDL, and the service name. And here we have some constants. In this case, is information name and send query. In this case, we deconstruct the object of data to add the method name that we are going to call. In this case, is the information for name, and we are going to call the method name. And once it's recovered, we set the FT name, recovering the result of the query. And also for the symbol, we recover the method name symbol. We construct the constant of the data of the query. For the decimals, for the total supply, and the minters. Well, if we click on preview, we can test the query, and it gives us all the information of the contract on this case, the BFT contract that we are going to call. Well, as you can see, here are the minters available on this contract, but I'm not part of this list. So we are going to show you another example that will be interesting to interact with it. Here we have, wait a minute, let me get the direction of the contract. In this case, it's an example of using another standard on Vara network that is the BMT. It's Vara multiple token, so we can create multiple tokens directly on this implementation. In this case, we are going to we are creating some tokens to interact with something like a Tamagotchi. Well, here we have the example. In this case, we have a burrito that we can interact with it like a Tamagotchi. We can play with it, we can sleep, and we can eat. And if we click play on it, on play in this case, first of all, we are going to burn the gold. I remember it because I'm going to do some transactions. And we execute the transaction to burn tokens. The gold is burned. And we mint the play counter to interact with the burrito and the animation change. And also we can sleep with the burrito. First of all, we burn the tokens of gold and we mint the sleep counter. And the animation change also. And now we can exchange this counter for XP. First of all, we burn the counter and mint experience. And also we are going to do it with the sleep counter. And now we have 100 of experience. So we're going to exchange this experience for another level. We burn the experience and we're going to mint another level. Well, in this case, it's an example using multiple tokens on only one contract using the variable multiple token standard. In this, we are using 6 tokens to interact with this Tamagotchi. And also, if you do click on up here, you can fork, in this case is edit. You can fork this component and make some changes, check how it works, and if you're interested in how Eternacode can in how you can implement something harder or different on Eternacode, you can send us a message on our group of Telegram, and we're going to check it and help you as soon as possible. Where if you have another question about the integration of Eternacode, we have the documentation up here, and you can access to all the information of Eternacode, how to interact with other things like fetch, async fetch, cache, and other things that will be interesting to you and help you on the development of your components. And also, you have the exclusive section of our network on how to interact with it. Did you have something? And you can check it on the documentation. Well, someone have questions or something? Something to tell about with us? If you don't have any question, I think that we can finish this session and see you on the next workshop. Fine. I think that there are no questions. There are no questions on the chat. So I think that we can finish with the recording and finish our session. Aditya, thank you for joining us. Thank you for your participation in this session. And we see you on the next workshop if you want. Thank you so much.
Thanks a lot. And the project is great. Just to tell you guys.
Bye-bye. Thank you so much. Bye-bye.